So hello everyone, and today I'd like to present to you some new features that I've been working on for my computer. So let's get started. So I will just reset it first, which will get me back to the bootloader, and I have two options here, either one, the memory monitor, or two, ATA boot, as you've seen. And this is the memory monitor, which is the default option. So after 5 seconds, the computer just boots into the memory monitor. And with this, I can, as the name maybe implies, look at memory, right? So I can do, for example, 0200.02ff, and this is hexadecimal, but it will just show me what is in memory at that address. I can also inspect a single address. So for example, if I do 0200, it will show me what's there. I can also write, so 8076, and if I inspect that memory address, I get 76 back. I can also obviously run, but I don't have any programs to run right now, but that would just work by doing 8000R, and the computer jumps at address 8000 and runs whatever code is there. But let's look at a more interesting option, which is option number 2 here, which is ATA boot. And this boots into my kernel, which uses colors. The terminal supports colors because I've updated the software. But there's only 8 colors, but I think that's enough for now. So I have booted into the kernel loaded a shell, and this is the shell that I'm typing at right now. So I can do some basic commands, like for example there's ls root directory, and this will show me whatever file there's there, and directories as well. Now this is a very simplified version of ls. It basically just takes in a directory, a path, with no flags or anything more complex. It's very, essentially it's just the name is common, because I wanted to have some familiarity when using this computer, but that's about it. I can also inspect the bin directory, and this shows me whatever programs I have on this computer right now. And so let's get started with Unicode, right? I have added to my terminal software a special escape sequence that can take in a UTF-16 encoded character and print it to the screen. Now it doesn't quite work, and I'll show you exactly why, but it kind of works, right? So if I do, for example, 3041, this will print a Japanese character, and I can also do 3042, and it will print the next character. But for example, if I first do help and I do 4E2D, this is the wrong character. You can check it, but that's not supposed to be there, right? I'm not sure what's happening exactly. There's a bug somewhere. But I can also test the colors, which work. So I can do, for example, yellow on black, and this will set the color, the foreground, the text color to yellow, and the foreground to black. I can also try maybe yellow, black on white, and this is the opposite, and you cannot see anything, but let me switch it back to white on blue maybe, and this is already more readable. And I'm not sure if this is supposed to happen. Like, as you can see, there's more lines. The lines just kind of turn into a block of blue. But the computer is freaking out, so I will just reset it quickly. Reset it completely, actually, because the image is flickering. CRTs are really hard are really difficult to film, and I missed my opportunity. So go to 2, and now I'm back in my kernel. So I can do some more stuff here. So for example, I can do cat test.text, and I need a /. This is another restriction. The file IO part of this is very not okay. It's very glitchy. So you always need that /. There's no relative paths essentially. But what I mean by glitchy is that, for example, if I do ls and I give it this file, you can see kind of how that works, but it just takes whatever content is there and it presents it as if it was as if these were files or directories when they're clearly not. So there's still a lot of work to do, and there's many glitches all around. By the way, there's also the monitor here, so I can go into the monitor, and this is the same thing except that it's written in C this time, but it does the same function, and I can exit using Q. It drops me back into the shell. Well, I say drops me back into the shell, but what's really happening is that the program goes back to the kernel, and the kernel automatically reloads the shell. So this is not the same shell that we started with, right? Is there anything else that I forgot? I don't think so, but maybe. No, I don't think there's anything else. I showed cat already in a previous video, and right now. If I type shell, it would just open a new shell, like as you'd expect. But anyway, that's all for now, and see you next time.